You're listening to the Interactome, a podcast by a group of young researchers who want to connect you to the world of science by sharing their stories and perspectives. Just in case their bosses are listening, they want to remind you that the opinions expressed here are their own. They also want to remind you not to take anything they say as medical or professional advice, as they are not doctors. Not yet, anyway. Stay tuned about that. And, without further ado, welcome to the Interactome.
Hello, everyone, and welcome back to the Interactome. I am one of your hosts today. This is Natalie. I'm super excited to be here. We've got another guest that's going to talk to us about some really interesting research that she's done. But before we get started, I'm going to pass it over to my co-host to also say a quick introduction.
Hey, everyone, it's Sarah. I'm super excited to be on the podcast with you guys today as we introduce our new guest. Her name is Rasa. She is an MD PhD student with me at Loyola Stritch in Chicago, and really excited for you all to get to meet her.
Welcome, Rasa.
Hey guys, it's great to be on. Really excited to talk to you and share about my research.
Woohoo! Awesome. So let's get started a little bit with telling our listeners about you. So maybe if you could start off with where did you go to school and what did you study, and how did you end up in medical school?
Yeah, sure. So I actually was born in Lithuania, and I immigrated to the United States when I was 9 in 2001, right before 9/11 happened. So it was a very tumultuous time. I was always really interested in medicine from the time that I was young. A lot of it stems from me being a really, really sick kid. I had pneumonia 3 times, bronchitis all the time, in and out of the hospital. And so I got really familiar with the healthcare environment. But what happened was in high school, I actually interned at a lab at Rosalind Franklin in North Chicago. And there I kind of grasped the larger picture and saw how I would be able to contribute to science and medicine by being a physician scientist. So that's what led me on the path of the MD PhD program and the MD PhD track. So I went to undergrad at UW-Madison in Wisconsin, where I studied neuroscience, and then my other major was languages and cultures of Asia, as well as a minor in religious studies, so kind of all over the place. I was, again, really interested in the humanities and how, the biology connects with humankind. And then I ended up here at Loyola, again, pursuing my MD PhD, and I just recently defended my PhD in neuroscience.
Congratulations, and busy with those minors. I'm sure, you were crunching those schedules, making sure that, you could all fit it in time. So that's very cool. And so you talked about defending your thesis. What is maybe at a high level your research background? Yeah,
sure. So my research background actually, again, goes back to me being in high school, right? So when it was 2009, I was a junior in high school at the time. And I was at a lab that studied the regulation of neuron activity in the context of Parkinson's disease and schizophrenia. So that's kind of where the neuroscience aspect really planted a seed. And I really loved the brain and understanding how we think and all of these diseases associated with it. And then when I went to undergrad, I joined a lab that studied exocytosis, which is this mechanism by which cells release chemicals that are used for cell-to-cell communication. And they studied this in brain cells. And then after I graduated, I actually worked as a technician for 4 years before matriculating into medical school. The first 2 years I spent in a lab that studied the role of an antioxidant transcription factor in preventing neurodegenerative diseases. So the whole idea of antioxidants being good for you and good for your health. And then I transitioned a little bit neuroadjacent to studying retinogenesis, which is the development of the retina, which is the layer of cells kind of at the back of your eye that really allows you to see. And studying these degenerative retinal diseases using stem cells. And then now getting me to this point. So again, it's been, almost a couple decades in the making now. So at this point, I am in a lab that studies a lot of things, but my dissertation focused on the role of diet in neuroinflammation. And neuroinflammation is just inflammation of the brain. And I think people are familiar with the term inflammation because it's been thrown around a lot, especially in recent years with different diseases, both in the brain and in various parts of the body. And so one thing that I'll say is, if ever anything I say is a little bit unclear, just ask me to clarify, because as PhDs, we know a lot about a sliver of a cake. So even though I am a neuroscientist, what I am actually an expert in is my dissertation and not really much beyond that. Even though I might have a bigger picture and understanding of neuroscience than the layman, my expertise really lies in this, understanding this role of the interaction of diet and neuroinflammation.
I'm trying to think of brain puns right now, but they're not coming to mind.
Well, there you go. Yeah. There's your first
one,
Natalie.
True. Unintentional. No pun intended. Sarah, I cut you off though. What were you saying?
Oh no, I was gonna say, like, Rasa, I think it's so nice to hear you say that, because I feel like, that's so true for all of us, right? Each of us on this podcast has our own kind of like very specific area of expertise, and it can be so easy to get caught up in that and, kind of assume that everyone knows what you're talking about. So we will definitely ask for clarification, but I'm really excited to learn more about your dissertation and just how diet affects the brain in general. What's a good starting point, right? Because I feel like there's so many avenues that we could approach it. And I think that you see this a decent amount too in like pop science. And so like as someone who's not catering to that pop science crowd necessarily, how do you typically start in explaining this really network of connections that link the diet and brain function?
Yeah, that's a great question. So diet plays a critical role in regulating the brain in several different ways. So I'll kind of try and break it down a little bit. So the first, of course, is just nutrient supply, right? Every part of our body needs nutrients. And so the brain requires actually a constant supply of nutrients because it's not able to store energy in like cells like the rest of our body can. So for example, if you think about fat cells, they are able to store energy so that when we're not getting nutrition, we're able to use that and our muscles are still able to work. But the brain requires a constant supply of nutrients because it really doesn't have a storage system. And there are some key nutrients like omega-3 fatty acids, which are found in fish, vitamins like B vitamins and antioxidants and minerals that are essential for various brain functions, including neurotransmitter synthesis. Now, neurotransmitters are, again, these chemical messengers that allow the cells in your brain to communicate with each other and transmit signals throughout your body to make your body work. So neurotransmitter production, again, begins at the level of these certain nutrients serving as precursors for these transmitters. So for example, if you think about tryptophan, which you might have heard about, this is an amino acid that's found in turkey. And the reason that we think about it a lot around Thanksgiving is because it kind of makes you a little bit sleepy. But tryptophan is actually a key precursor in several neurotransmitters. And so it's really important to get molecules like that into your body through nutrition. Another way that diet regulates brain function is involved in brain plasticity. So plasticity is the ability of your brain to just kind of change with time and with what your body needs. So diet influences that by providing things like antioxidants, for example, right, which are found in lots of like fruits. If you think about berries, blueberries are super rich in antioxidants, and they help protect the brain cells from something called oxidative stress, which are these, again, molecules that are detrimental to these cells. And then there's also, of course, inflammation, right? And that's kind of where I'm at with my dissertation process, in that there are certain foods that, just like they affect your body in a pro-inflammatory way, they also affect your brain in that same type of way too. And of course, there are certain foods that are known to be anti-inflammatory, like, again, fruits and vegetables and healthy fats. And then there's all of this research ongoing now that's really hot, and like it's pop science-y too, but I think the field overall is really interested in understanding this, which is this gut-brain axis. We learn about it a little bit in medical school, but really, like, there's emerging research that suggests that the gut microbiota, which are like the bacteria in your gut, they really have a critical role in regulating brain function and even mental health. So diet, of course, really has a huge contributing factor to the type of bacteria that are able to grow in your gut. And so that's another way that diet is able to regulate brain function. And so my work, of course, like I said, focused on the inflammatory connection. And I became interested in this because there's actually a massive connection between type 2 diabetes and Alzheimer's disease, where the risk is actually nearly twofold. But that connection isn't well understood. So I chose to study something called a high glycemic index diet, which some people might have heard about because it's a diet that essentially really spikes your blood sugar instantaneously, and it comes from all of these processed foods. And so I wanted to see if this diet is going to cause inflammation in the brain that could potentially contribute to neurodegenerative diseases like Alzheimer's.
Awesome. That was a great overview. Really appreciate that. The twofold stat is pretty crazy. And I think too, when you brought up the high glycemic index diet, and just as a clarifying point for our listeners, that's a bad thing, right? For somebody, like maybe for a human to have a high glycemic index diet, if it's linked to diabetes, then it's typically not the ideal human diet.
Yeah, correct. So the reason that it's not ideal, now there are high glycemic index foods, and some, for example, like watermelon. Watermelon is considered a high glycemic index food. And the reason that is because it has these simple sugars that are really easily processed by the body. So it doesn't take very long for your body to break down these sugars and release them into the bloodstream. And so you cause a blood spike in sugar that quickly comes down. So if you think about eating lots of candy, right? Like this is exactly what happens, a sugar high and then a crash. But again, it's all about balance, right? So watermelon, we think about that. That's a fruit. That's a delicious thing to eat on a hot summer day. And we think of that as a healthy alternative to something like ice cream. So again, it's all in balance. And there are foods that do have a high glycemic index diet or high glycemic index that are still beneficial for you and have nutritious value. It's just that you want to make sure that your entire diet isn't high glycemic index.
Gotcha.
So what is the difference between either a low or a normal glycemic index food and a high glycemic index food, right? Because like the question in my mind right now is like, how do I know, right? Because I had no idea watermelon was a high glycemic index food. And I'm sure listeners are wondering too, like, is there a numeric cutoff? Like, how can people sort of tell if they're eating in that zone or in a different zone?
So glycemic index is kind of arbitrary numbers given by individuals to see how your body reacts to the sugars that are in the food. So it ranges from 0 to 100, and 100 is given to pure glucose. So that's just you essentially dumping sugar into your body. So I forget exactly what kind of organization does this, but they actually go in and test foods to see how they affect your blood glucose over time. And so this is how those values are determined. So if you want to know the glycemic index of a food, you actually just can pull up any, like there's a number of charts found on the internet, and they'll all agree because they're all from the same organization. But that's how you can know what kind of glycemic index a certain food can have. But in in a general way, if you don't have access to the internet, for example, you can really think about like, is this food something that is heavily processed? Is it really sweet, for example? Or does it have a lot of fiber? Because fiber really affects the way that our body processes sugar. So if you think about something like watermelon, because watermelon is so watery, but it also is very sweet, it really is just like, in a way, eating sugar with some water, if that makes sense. Whereas if you eat something like an apple that has a lower glycemic index because it has all of that fiber that your body has to break down through too.
Gotcha.
Okay, that makes sense. Yeah. I know you mentioned, a high glycemic index and the link to diabetes, and I think that's an important aspect of your research as well. So maybe for our listeners, are you able to kind of walk us through the differences between type 1 and type 2 diabetes?
Yeah, I think, so there's a couple of differences. They're both, from what I should say is they're both chronic conditions, but they can have different causes, risk factors, and the way that you approach treatment for these individuals. And both of these conditions affect how your body regulates blood sugar. And so the cause of type 1 diabetes is autoimmune. So essentially, your immune system attacks these cells that produce insulin in your pancreas. And so as a result, your pancreas produces either little or no insulin at all. And so insulin is a hormone that's necessary for glucose to be uptaken into your cells for energy. And so it's really detrimental, obviously, to your health to not be able to do that. A lot of these individuals you'll see will have, again, like fatigue. They'll be very emaciated. So not great. And then the exact cause of type 1 diabetes is actually not known. I should state that. Like a lot of autoimmune conditions, it's really complex and always under study. And then type 2 diabetes occurs when your body becomes resistant to the effects of insulin. So whereas in type 1 diabetes, you don't have any insulin, here you have insulin, but the receptors that need to sense insulin become resistant to it. And that often is because of lifestyle factors as well as genetics playing a component. So typically, as far as when these conditions appear, type 1 diabetes usually comes on during childhood because these people are typically born with it, and autoimmunity starts pretty early. And then type 2 diabetes typically develops in adulthood, although because of kind of our changing diet in this country, we are seeing more children and adolescents developing type 2 diabetes, particularly because of the rising obesity rates. And so as far as symptoms, I kind of mentioned a little bit about type 1 diabetes, but type 1 diabetes is pretty rapid, and you have typical diabetic symptoms like increased thirst, you go to the bathroom a lot. Here you actually have unexplained weight loss, again, because your body isn't able to take up glucose into your cells, the fatigue that I mentioned, and then some maybe visual changes. So again, without insulin replacement therapy, children with type 1 diabetes used to die. And so the invention of insulin was actually a really life-saving drug for these kiddos. And then type 2 diabetes, the symptoms honestly usually progress more gradually because this is related to more lifestyle factors and develops into adulthood. But they are pretty consistent with type 1 diabetes, aside from weight loss isn't as common in type 2 diabetics. And then they also have really slow wound healing. And that, again, goes back to a very complex biochemical process that occurs in the body. They have a lot of issues as adults. And then as far as type 1 diabetics get treated with insulin, because again, they lack insulin. So insulin replacement therapy is what's needed for them, lifelong insulin replacement therapy. And type 2 diabetics, there is plenty of drugs out there that are able to manage this disease, but actually in a lot of cases, lifestyle modifications can even reverse type 2 diabetes, which is why, again, I became interested in more this topic and this connection because I really think that there's a lot that we can do to modify our lifestyle to prevent these detrimental diseases.
Absolutely. So cool. And thank you for that breakdown. It was really helpful. As for your research in particular, you weren't studying humans. You were studying mice. I think that's important to kind of get out there for the listenership. And what was your research trying to answer?
Yeah, so my research was trying to answer how the carbohydrate composition in the diet affects neuroinflammation in the brain. So to do this, what I chose to study was a high glycemic index diet, which I already explained to you all. It really was composed of refined sugar that was readily metabolized in these mice. And so the glucose was rapidly released into the bloodstream. And then on the flip side, the second diet that I chose to study was the ketogenic diet, which I think a lot of our listeners have heard about because it's a popular weight loss diet out there. It is a diet that heavily restricts your carbohydrates. So most of your calories actually come from fats. And in my study, the fats in our diets came from plant sources. So it was very, very limited in carbohydrates, high in fats, and kind of moderate amount of protein in both diets. And we found actually what was interesting, that the high glycemic index diet did not increase blood sugar like we would expect, and that the ketogenic diet did this instead. But I think this is, again, gets back to your point that I studied this in mice and not in humans. So humans are very different. Mice have a very different metabolism. They are nocturnal animals. So I think it's really important to take my study findings in the context of the design of the study, correct? And so what we found is that long-term administration of a high glycemic index diet led to inflammasome activation in the brains of male mice. So what an inflammasome is this massive protein that initiates inflammatory responses in your body. And it regulates a lot of different inflammatory pathways. So it's been implicated in so many diseases, everything from, again, Alzheimer's, diabetes, atherosclerosis, arthritis. So any number of diseases you can think of, an inflammasome probably plays a role because it is this like master regulator of inflammatory responses. And so again, we found that the high glycemic index diet increases inflammasome activity in the brain of male mice. But it didn't do this in the female mice. In the female mice, we actually found that the ketogenic diet increased this inflammasome activity. And I think that's really interesting that we found a sex difference because until recently, it wasn't really required for researchers to study sex as a biological variable. And so just like in a lot of our clinical trials, what we saw is that a lot of these trials were done in male subjects. In mice, it was the same thing. A lot of times investigators were choosing to use mice or to use male mice. And now actually the NIH is, in terms of funding different grants, they are more and more requiring investigators to address sex as a biological variable because of these types of differences that we were able to see. So I think it's really important to think about, again, when we see things out in the media that say like, hey, like, for example, keto diet is great for weight loss. Well, you have to think about, is it great for weight loss for men? Is it great for weight loss for women? And in addition to weight loss, what else is it doing to your body, right? So all of these things, I think, again, while the findings have to be taken in the context of it as a rodent study, it is important to think about how this plays into the bigger picture of human health.
And you bring up so
Definitely.
many good points, especially about just how research is structured, right? Like you need that variability, and you need to be able to know like what the difference is between sex for all diseases. And I think it's interesting that you mentioned that that the NIH now is requiring that. I think it's about time, right? Like I think that's how you get the best treatment for disease, by having a wide variety pool. And I think that, too, to your point, is something that folks should consider when seeing like headlines about research study found XYZ. And it's like, okay, it's one study that looked at one sample size and got X result. That doesn't mean it's, set in stone, or it's kind of like now it's like a law of physics or something that like can't be changed. Mm-hmm. So that's really interesting. Were you surprised by those findings?
Yeah, we definitely were. I think we were, first of all, surprised that we didn't see that spike in blood sugar that we thought we'd see with the high glycemic index diet, because that's what would logically make sense just based on, essentially these mice were being just fed straight sugar, right? So you would think it doesn't matter, it's a mouse or a human. If you eat straight sugar, it just goes into your bloodstream. But it's interesting because mice have just a different metabolism, and they're able to regulate all of these, different systems differently than we are. And so it's always really important to think about, again, that's why we have, a control in every study that we do, because it is really important to think about the physiology of the animal that you're studying. Unfortunately, human diet studies are really hard to do because it's hard to tell a human what they should or what they can and cannot eat, right? So even if you're going to say, Sarah, I will sign you up today for an experiment and you are supposed to stick to this diet. A lot of times, honestly, as humans, we're not even conscious of the things that we're putting in our mouth. I talk about this with my mom all the time. She's like, oh, I haven't eaten anything today. And I'm like, are you sure? Or did you just like eat as you were like, busily driving or walking along and you just don't remember that you ate something?
Right.
Mm-hmm. So I think it's hard. And a lot of diet studies in humans do rely on self-reporting because, again, especially, to carry out a diet experiment, you need it to be long-term. You really do. And so it's not like you can house people just in hospitals or something for, 6 months, a year, and have them just eat a very strict diet. So what you're relying on is telling them what they can and can't eat and kind of the general, criteria, kind of if someone were to give you a food pyramid and say like, you can eat this, but not that. And then you're relying on self-reporting. Yeah. You're relying on the fact that they'll remember what they ate and that they'll accurately report it to you. So there are a lot of caveats in human research. And so I think because there is that drastic variability, you need a large sample size. And so that's some of the problems that are out there with human diet studies, is that unfortunately it's just really hard to get a large sample size for any study. And especially, again, people oftentimes don't want to, be told what to eat. But I think any findings that we have just add to our current existing knowledge base. And so, like you mentioned, Natalie, you a lot of times will see headlines because, especially pop culture, like magazines or news websites, really want to
especially when it comes to diet.
Exactly.
Right? Like, to lose weight or,
Yeah, exactly. Kind of so they really want to grab your attention and like sell you on something. And it's interesting because you'll sometimes read a headline and it's just so like, wow, oh my gosh, this is amazing. And then they'll cite the study and, having a background, a PhD, I'll always click on the study and I'm like, I don't think this is as impressive as they said it was, But for the lay population that hasn't gone into graduate level education, it's hard to interpret all of that data. And so I think it's really unfair for people to be asked to be like these policemen when they don't necessarily have the knowledge base. And so I think we do need to do better with just reporting the data for what it is and not really trying to sell something.
I'm going to go on a tangent really quickly. And Sarah, I think that you would be a great person to also answer this question. When you're, and for listener background, if it's helpful, I did 4 years, I did undergrad. Rasa and Sarah are both in medical school doing advanced education. So they have more of a research background than I. When you see maybe a headline like that, that catches your eye, right? It's like, maybe it's like people who eat, 100 pounds of chicken a day end up losing 30 pounds in 6 months. Like, that's like a crazy thing, whatever, but that's going to catch your eye. When you're looking through that study, what are the key things that maybe you're looking for to legitimize it when you're kind of doing your due diligence? And what would you recommend that readers of, that are consuming these articles and learning these things through mainstream media know or learn to further be able to kind of think critically about what they're reading?
That's a really good question and a really important question. I'm going to answer it first because I feel like I have like in this like tier of knowledge, I feel like I'm right in the middle of us three because I'm in medical school, and I've done a bit of research, but I have not done a PhD, right? So I think it'd be interesting to kind of see like what we each look for. I think in terms of just research in general, one of the first things I look at is sample size. Like sample size, and then who are the people that they're studying if we're talking about human research. But sample size is big for me because I'm like, okay, this is really going to play into the statistical power of the study and the statistical analysis that they do later. And that can really tell you a lot, I think. It's like, I think it can tell you a lot about further implications just off like the one thing. So I'd say that's the big thing I look for. And then also for me, and maybe Rasa, you can speak on this more, but like how certain people have acquired the data. And I guess that kind of goes into the second part that I was touching on about like who they're picking. So if a study is retrospective, so looking back into medical charts, for example, that might be more freeform in what data you're able to pull compared to a very specific sample size of a group of patients, let's say, that you follow for a year into the future. So I think like that also kind of plays a role. But I think ultimately it probably depends on what the study is and what conclusions you're trying to draw. But number one for me, let's go with sample size. Rasa, what do you think?
I think I would agree with you. It's hard to think about, putting myself in the shoes of someone who doesn't understand statistics at all, for example. And so, because really what I do immediately is I don't read the text. I just go to the figures and I analyze the data for what the data is. But I think if I were to dissect an article, the first thing I would look at is the title, right? Like, what is the claim that they are making? The second thing I would look at is the method section. And so here, yes, just like Sarah said, I would absolutely look for the sample size. And I would look at the types of statistics that they used to run, or that they chose to run on this data. And I would also look at, like Sarah mentioned, if again, this is a human study, I would look at the population. Did they include both males and females? Did they include all races? Did they include all ages? And did they account for these things, right? So for example, let's say you are comparing cardiovascular health. If your sample includes people that are men, women, white, black, Asian, and they span in ages from 18 to 75, well, I sure hope you're not comparing an 18-year-old male to a 75-year-old female, because those things need to be separated, right? So again, this goes back to really understanding how the study was designed, like Sarah mentioned. I think the other thing that I always look at is conflicts of interest. So that's actually found at the very end of the article. Because if you see that one of the authors of the article, for example, is somehow involved in a drug company that is the drug that is, studied in this article, that is an automatic conflict of interest. So I would not personally trust anything that comes out of that research, because you just can't separate them.
Even if it's out there and in the paper, like, that it's still, it's bias, right? It's just bias that,
Yeah.
Correct. And I think the other thing that I would look at is, again, I would, even if I didn't necessarily understand the data, I would look at it and I would see the claim, because they will always have a little conclusion section, just a couple of sentences. So I will read that conclusion and I will say, are they making a statement that is beyond what they actually found? So, for example, if we studied, let's say, again, back to cardiovascular disease, and we study this cardiovascular disease in a population of, 30 to 50-year-old men in, Tanzania, right? Now, whatever they found, are they then saying that this entire study can influence the way that we interpret data for all humans across the world, right? Because you have to think about, again, these specific people in Tanzania, they eat a very particular diet, they have a particular lifestyle. You can't possibly think that this will reflect, the world population. So it's just a matter of, are they being more liberal with how they are interpreting their results, right? Because I think that will tell you whether kind of like their level of trustworthiness. Because I know I am always and I've been trained to be very careful in not over-interpreting the data that you found.
That's so helpful. And I say that I sound like a broken record every time we record an episode, because that skepticism that is so core to science and to seeing results and seeing kind of just impact of your work, of your research is, I feel like we hear a lot about skepticism around science. And I think at their core, scientists are skeptics. And that's a good thing. To be skeptical is a good thing, to make sure that, you're actually getting accurate information delivered to you. So yeah, that's super helpful. And I'm going to keep that in mind for myself personally. All right, I'm done derailing us, but, we were talking about this.
No, that was good.
A really important thing to note.
Honestly, Rasa, that was so well said. I'm literally going to be playing this episode back for myself, before I sit down to do a literature review. Be all right, what are I'm going to look at the sample size and then the methods and the figures.
We'll call it Rasa's rule.
Yeah, Rasa's rules.
So just to kind of bring it back to your research. So, and correct me if I'm wrong, but in summary, you found that long-term administration of a high glycemic index diet led to inflammasome activity, if you can call it activity, in the brain for male mice. And the same inflammasome activity was seen in female mice on a keto diet. Why, and maybe, your team isn't there yet, and no, you haven't kind of dug into this, but why do you think that is?
Yeah, I think a lot of it likely has to do with different hormones. So obviously males and females possess very different sex hormones, and hormonal regulation between the different biological sexes is kind of a very intense field and very complicated. So I think that is probably what it comes down to, the way that our bodies just process different nutrients differently, the male and the female body. We're not completely sure why exactly we saw this phenotype with the inflammasome, but we are like actively figuring out the pathways for this. So hopefully I can update you guys in a future episode.
And how does, yes, you're always welcome back. We love repeat guests, our boomerangs. What, and just to clarify, because we talked about diabetes a little bit towards the top of the episode, how did this research, like were these mice diabetic? How did diabetes maybe feed into this hypothesis and research?
Yeah, that's a great question because I don't think we kind of
I think we glanced over that. Yeah, I'm realizing that now.
So the way that diabetes, the idea of diabetes fed into this is basically, so we talked about the connection between diabetes and dementia, like Alzheimer's disease. And so I wanted to see, obviously, because diet really plays a huge role in the development of type 2 diabetes specifically. And diet is actually also known to be a modifiable risk factor in Alzheimer's disease, which is interesting. So I thought, okay, so there is an overlap there. And then the high glycemic index diet came into play because I thought, wow, a high glycemic index diet is known to disrupt the glucose metabolism so much that if it's persistent, if this is the type of diet that you're eating day in and day out for years, it can lead for you to develop insulin resistance and type 2 diabetes. And so the entire theory behind this was that if I place these mice on a high glycemic index diet, they would have glucose intolerance, which is indicative of diabetes. Now, of course, we didn't see that phenotype, but that is kind of how that connection formed in just understanding, diet impacts both of these pathologies. The inflammasome is somehow involved in both of these pathologies. Maybe diet is the link between diabetes and Alzheimer's disease by modulating the inflammasome.
That's fascinating. Yeah, I'm just thinking about, right, we're going kind of quiet
No,
here.
me too.
Yeah, it's kind of like, wow, could it be, right?
I'm in thought.
A second to ponder, if you will. No, but that's really fascinating. And I think, science research just bodes more questions. So, yeah, looking forward to finding that out through other people's work because I don't do research. So while we're wrapping up here, wanted to kind of end with more of like an open-ended question to just get your thoughts. We talked a lot about how diet and over the course of, years, right, when we're talking type 2 diabetes being brought on by diet, it's not, you eat a donut, right, and all of a sudden you have type 2 diabetes. It's a systemic issue. So what do you wish that maybe was more widely discussed in the conversation of diet and wellness, especially in our culture, Western culture, that's so obsessed with diet and things like that?
Yeah, I think one thing that's always on my mind is how to make things equitable. So it's very easy, I think, for us in research and in medicine to sit there and say, well, here are the facts. Here is the food that you should be eating. This is what will improve your health. I think there is the factor that needs to be considered is that not everyone has the same access to all the food. So, 100%. For example, there are so many food deserts in this country where people don't have access to a grocery store. There are so many people who are working very difficult jobs, sometimes multiple jobs, raising families, and don't have the time to cook meals at home. So I think it's really difficult because you want to make these recommendations, yes, because you want people to understand the food that is good for their bodies and the food that could be harmful. But I think really, instead of us kind of as medical providers or as scientists dictating on an individual basis and advising people what they should and shouldn't eat, in addition to that, I think we really need to like come together and approach our policymakers about systemic changes that need to happen to make nutritious, healthy food more accessible, to ensure that, for example, you know, I know I actually just saw an article today that the Biden administration has passed a policy changing a little bit of the guidelines for school lunches. So, for example, you know, doing things like this to ensure that people who really need access to good and nutritious food get that access. So that's kind of what I'll leave you to ponder with, because I think everyone can do their part in that.
Yeah, absolutely. It starts with equity.
Yep.
Well, thank you so much, Rasa, for coming on the show. It's been so nice to talk to you about all of this. And I mean, I knew that you had defended your PhD recently, but I didn't realize this was the extent of all your research. And so personally, I want to say I'm very, very proud of you. But I think this is a great project. I think it led to so many other hypotheses that can be taken and run with. But it was so nice to talk to you about all of this. And hopefully we'll get to see you again in the future on another episode of the Interactome.
Absolutely. Thank you so much for having me on. And if in the next episode I say that what I found out was all crap because this new study that I studied found something different, you know what? This is science. Like, I think that's just another thing that I want to say and leave your listeners with is science is constantly changing. I know in the COVID pandemic, there was a lot of frustration with the administration constantly changing rules and regulations, but this is just the reality of science. It would be detrimental to our progress as humankind if we didn't continue to seek like truth and to believe something is fact and not question it, right? So it's important, I think, for others to kind of validate our findings. There is some literature to suggest that this, you know, all of this is kind of coming together. But again, you know, I'm not going to be mad if someone down the line says, no, actually, we found something completely different. Because again, every study and its findings needs to be taken in the context of the methodology that you used, kind of like we discussed and Sarah will be reviewing later on.
It is a scientist's dream, I hope, to do research that eventually becomes irrelevant someday, right? Because that's how you know progress is actually being made, right? Everyone wants their research out there, but they also want someone to dispute it, I guess, right? And like that's the true nature of science. And I don't know, it's nice.
What a great closing. I've never really heard that perspective. I think that's really valuable and one we haven't highlighted on this podcast. So thank you so much, both of you, for highlighting that.
Yeah, it was great coming on the show.
Yeah, and we loved having you. If you are looking for us on social media, we are at Interactome Media on Twitter, and then _@ the Interactome. It's going to be in our bio. I mess up what our handle is literally every time, so this shouldn't be a surprise.
I think it's reversed.
Is it reversed? Oh, well.
I think so. I think it's at Interactome _media on Instagram. And at the Interactome on Twitter.
That's what I said. So. Yeah, that's right.
Yeah, that's totally what I said. It's fine.
All right. Well, thanks again for tuning in, everyone. And thanks again for joining Rasa. And we'll catch you in the next one.